Students, we are given this question. The growth of a population is proportional to the number present. If the population of a colony doubles in 50 years, in how many years will the population triple? So the solution to this question is obtained as follows. Foremost, let us take x of t be the population at any time t. Okay, so this would mean the change in population dx over dt is going to be some constant times kx. Now, using the techniques that we have studied, I can rewrite this to be as dx. I can bring the x down and I can move the dt to the right. So I've got something like this. Now, integrating, we would get, when I integrate this, I would be getting, this is going to be ln x, this is k times t, positive constant c. Now, I can simply write the constant c if this is not an application question. Okay, this is an application question. So instead of writing constant c, I'm going to write it as ln c. So this is also a constant because this is an arbitrary constant, right? So that would mean I have the power to choose the constant. So that is the simple meaning of having it as an arbitrary constant. So now I would move this ln c to the left. So that would give me ln x negative ln c is equal to k times t. Now we have studied a formula. Ln a negative ln b is equal to ln of a over b. Okay, now by this formula, this is going to be ln of x divided by c is equal to kt. Now we have also studied a formula that ln a, if it is equal to b, then I can write a is equal to e raised to the power b. By this formula, this can be rewritten as x over c is equal to e raised to the power k times t. And from here, I can write x to be equal to c times e raised to the power kt. So this is my required equation to solve the question. Now what I'm going to do is, I'm going to take the following assumption. Now, at time t equal to 0, let the population, in this case it is x, be equal to x naught. Okay, so if I were to take this as 1, therefore 1 can be rewritten as, in place of x, it's going to be x naught is equal to c times e raised to the power k times 0, because time t is taken to be as 0. So this would mean this would become 1. So from here I would get c is equal to x naught. So if I were to rewrite this, okay, I can, instead of c, I can use x naught. Okay, so therefore 1 can be rewritten as x to be equal to x naught times e raised to the power kt. So this is what I have got. Now, it is said in the question, when t is equal to 50, the population doubles. Okay, the population becomes x is equal to x naught. So if I were to take this as, say, sum 2, therefore I can write 2 to be as, in place of x, I'm going to substitute 2 times x naught, and that is going to be equal to, of course, c is x naught and e raised to the power. In the place of t, it's going to be 50, and I already got a k there, so just place it like that. Now, if I were to cancel this x naught, then I would get 2 to be equal to e raised to the power 50k. But I want to know what exactly is the value of k. So what I'm going to do, I'm going to take ln both sides. So taking ln both sides, we get, so what do we get when we take ln both sides? On this side, maybe I can take this as 3. So therefore 3 would be rewritten as ln 3 is equal to ln e raised to the power 50k. Now you have to understand, if you have ln and you have e raised to the power 50k, by using this formula ln a power b, I can write this as b times ln a. Okay, by this I can rewrite this as, in fact this is ln 2. Okay, it's not ln 3 because we got 2 there, so it's going to be ln 2. So we can rewrite this as ln 2 is equal to 50k times ln e. But this is actually to the base e. We know that. So what do we know? We know that ln e to the base e is equal to 1. Okay. So by this formula, this is going to be equal to 1. So this would mean I've got 50k is equal to ln 2. Therefore, k is equal to 1 over 50 times ln 2. So this is the value I've got for k. Okay. So therefore, the original equation, now we have taken the original equation to be as x is equal to, right? X is equal to, of course, in place of c is going to be x naught, and you got e raised to the power kt. So this is the original equation. Now I can rewrite this by using the value of k. So that's going to be x is equal to x naught and e raised to the power, in place of k is going to be 1 over 50 ln 2, and you have a t there, so there is a t there. Okay, so this is the way you need to write, but this has to be simplified. Now this is just to show you the simplification part. Okay, now you have to know that if you have something like this, a raised to the power m times n, then I can rewrite this as a raised to the power m, the whole raised to the power n. Okay, so have that in mind. So this is a very important concept that you have to know to understand the simplification. Now k is equal to this. Now we know that a times ln b can be rewritten as ln b raised to the power a. So by this, I can rewrite k equal to 1 over 50 times ln 2 as ln 2 raised to the power 1 over 50. I can write this. But the original system that we know is the following. We know that x is equal to x naught times e raised to the power kt. So I'm going to rewrite this as x naught e raised to the power k, and that is raised to the power t. Why? Because a raised to the power mn can be rewritten as a raised to the power m within parentheses, and then that is raised to the power n. So that is why I am able to use this concept, a raised to the power mn over here. Now k is this value, we have found that out, so substitute that. So that is equal to x naught times e raised to the power, in place of k it's going to be ln 2 raised to the power 1 over 50, and that has to be raised to the power t. Now you got to know one important concept, that is e raised to the power ln a, the e and the ln they get cancelled, you will get ea. So using this concept where e raised to the power ln a, the ln and the e gets cancelled, giving you a, the e and the ln they get cancelled, so I would be left with 2 raised to the power 1 over 50, and that is raised to the power t. So this is what I've got. Now you have to know another formula, a raised to the power m raised to the power 1 over n is written as a raised to the power m over n. It can also be rewritten as a raised to the power 1 over n, and that raised to the power m. Okay, so by these information, this can be rewritten as, of course you need to place x naught there, therefore x is equal to x naught times 2 raised to the power, now 1 over 50 raised to the power t can be rewritten as t divided by 50. Okay, so therefore the required population at any time t is given by x equal to x naught 2 raised to the power t divided by 50. So this is how the final answer is written. So have that in mind.